Good afternoon to all of you. Welcome to this session.
Sir, namaskar.
Madhusmita, are you available?
Good afternoon, sir.
Ah,
Good afternoon, sir.
voice is audible. Voice is
Sir,
audible.
namaskar.
Yes,
Namaskar.
sir. Yes, sir. Audible.
ତେଣୁ ଆଜିର କ୍ଲାସ୍ ଆରମ୍ଭ କରିବା. We are going to start. ମୁଁ ତମକୁ ଆଜି ପ୍ରଥମରୁ ଯେତେ ଯାକ ଇମ୍ପୋର୍ଟାଣ୍ଟ ଥିଓରିଜ୍ ଅଛି ମାନେ ବିଗିନିଂରୁ ଏଣ୍ଡ ପର୍ଯ୍ୟନ୍ତ ଯାହା ଯାହା ତମର ଆସୁଛି କିଛିଟା ଡିସ୍କସ୍ କରୁଛି. ତମର ଯୋଉଠି ଡିଫିକଲ୍ଟି ଅଛି ୟୁ ଜଷ୍ଟ ଟ୍ରାଏ ଟୁ ପୁଟ୍ ୟୁର କ୍ୱେଶ୍ଚିନ୍ସ ଅର୍ କ୍ୱେରିଜ୍. ଠିକ ହବ? ଓକେ?
Okay, sir.
ଯେତେ ଯାକ ତମର ଇମ୍ପୋର୍ଟାଣ୍ଟ ଥିଓରିଜ୍ ଆସୁଛି ଯୋଉଟା କି ତମର ମାନେ ଅଣ୍ଡରଷ୍ଟାଣ୍ଡିଂ ଭିତରକୁ ଆସିବା ଦରକାର. ତାପରେ ଆମେ କମିଂ ଦିଟା କ୍ଲାସରେ ବାକି ଲିଙ୍କ କରିବା. କିନ୍ତୁ ଯୋଉ ଥିଓରି ଯାକ ଆସିବ ସେ ଥିଓରି ଯାକ ତମକୁ ତିନିଟା ରିଲେଟେଡ୍ ଟୁ ଫାର୍ଷ୍ଟ ଅର୍ଡର ଲ୍ୟାଣ୍ଡ ଫର୍ମସ୍, ଟୁ ସେକେଣ୍ଡ ଅର୍ଡର ଲ୍ୟାଣ୍ଡ ଫର୍ମସ୍ ଆଣ୍ଡ ଥାର୍ଡ ଅର୍ଡର ଲ୍ୟାଣ୍ଡ ଫର୍ମକୁ ଏ ଭାବରେ ଆମେ ଆଗ ଡିସ୍କସ୍ କରିଦେବା. ତାପରେ ଆମେ ନେକ୍ସଟ କ୍ଲାସରୁ ଯିବା. ମୁଁ ଭାବିଥିଲି ଏଇ କ୍ଲାସରୁ ଯିବା ପାଇଁ. ଆଇ ୱାଣ୍ଟେଡ୍ ଟୁ ଟେକ୍ ୟୁ ଟୁ ଦି କୋର୍ସ ଷ୍ଟ୍ରକ୍ଚର ଆଟ୍ ଦିସ୍ ମୋମେଣ୍ଟ. କିନ୍ତୁ ପ୍ରଥମେ ଭାବୁଛି ଆଇ ସୁଡ୍ ଡିସ୍କସ୍ ଦି ଟପିକ୍ସ ରେଦର ଦେନ୍ ଦି କୋର୍ସ କଣ୍ଟେଣ୍ଟ. ତାପରେ ଆମେ ନେକ୍ସଟ ଦିଟା କୋର୍ସ କଣ୍ଟେଣ୍ଟକୁ ଯିବା. ତେଣୁ ଆମର ଫାଷ୍ଟ ଯେତେବେଳେ ଆସୁଛି when we are going to study the first order landforms. First order landform ରେ ଦିଟା important theories coming before us. Continental drift theory of Alfred Wegener. ଆଉ ହେଲା yes. Anybody wants to speak something? Okay. So we are going to the topic continental drift theory of Alfred Wegener, which is the theory that relates to the origin of the first order landforms, continents and ocean basins. How continents and ocean basins have been created, and as per the theory of continental drift, and how the continental drift theory explains various features of the Earth's surface. Therefore, then subsequent development to the continental drift theory is the plate tectonics theory of Tuzo Wilson and James Morgan. These are the two people who have given this theory. And Ibanaka theory is plate tectonics, which is one of the most recent tectonic theories of explaining the first and second order landforms. Origin ku bujhaye. So we will be discussing that. First order landform is the important theory. ତାପରେ ଯେତେବେଳେ ଆସିବା ଆମେ ସେକେଣ୍ଡ ଅର୍ଡର ଲ୍ୟାଣ୍ଡଫର୍ମକୁ ଦେନ୍ ତାପରେ ଫାର୍ଷ୍ଟ ଅର୍ଡର ଆଉ ଗୋଟେ ଜିନିଷ ଅଛି. ସେକେଣ୍ଡ ଅର୍ଡରକୁ ଯେତେବେଳେ ଆମେ ଟ୍ରାନଜିଟ୍ କରୁଛେ ମାଉଣ୍ଟେନ ବିଲ୍ଡିଂ ଥିଓରିଜ ଗୁଡେ ଅଛି. ଦେयर ଆର୍ ନମ୍ବର ଅଫ ମାଉଣ୍ଟେନ ବିଲ୍ଡିଂ ଥିଓରିଜ. ତା ଭିତରେ ଗୋଟେ ଇମ୍ପୋର୍ଟାଣ୍ଟ ଥିଓରି ହଉଛି ଜିଓସିନକ୍ଲେନାଲ ଥିଓରି ଅଫ ଆର୍ଥର ହୋମ୍ସ. That is another important theory that relates to mountain building. ତେଣୁ ଏଇ ତିନିଟା ଥିଓରି ବର୍ତ୍ତମାନ ଡିସ୍କସ୍ କରିବା. ତାପରେ ଦେନ୍ ୱିଲ୍ ମୁଭ୍ ଓଭର ଟୁ ଥାର୍ଡ ଅର୍ଡର ଲ୍ୟାଣ୍ଡଫର୍ମ. ଥାର୍ଡ ଅର୍ଡର ଲ୍ୟାଣ୍ଡଫର୍ମରେ ଆମର ଦିଟା ଥିଓରି ଆସିବ ଯୋଉଟା କି ଆମେ ନେକ୍ସଟ କ୍ଲାସରେ ବି ଟିକେ ଡିସ୍କସ୍ କରୁଥିଲେ, ଷ୍ଟାର୍ଟ କରିଥିଲେ. ୱିଲ୍ ବି ଡିସ୍କସିଂ ଅବାଉଟ୍ ଦି theory of cycle of erosion of William Morris Davis and the non-cyclic theory of evolution of landforms by Walther Pank. And then the landscape evolution by L.C. King. एमती तीनटा theory रही which is related to the third order landforms. तापरे आसुची या परे आसुची हमरो slope development theories. Slope development theories of Davis, slope development theories of Gilbert, then slope development theories of तमरा आउ कोर्स रे अछि बदे probably Streller. ये सब जिनस रही. अच्छा, फर्स्ट ऑर्डर लैंडफॉर्म रे आ गोटे थ्योरी रही, थ्योरी ऑफ आइसोस्टेसी, सेटा भी रही. तेणु दीज आर द इंपोर्टेंट थ्योरीज व्हिच वी आर गोइंग टू डिस्कस. तो आज आमे ए जाको टिके सब थ्योरी विषय रे टिके जानि देबा, सो दैट कंपैरेटिवली वी नो, ट्राई टू अंडरस्टैंड हाउ द थ्योरीज आर डिफरेंट फ्रॉम ईच अदर, हाउ द थ्योरीज एक्सप्लेन द ओरिजिन ऑफ द लैंडफॉर्म्स, लैंडफॉर्म को ओरिजिन करिया पे केमदी माने हाउ दिस थ्योरीज आर यूजफुल एंड व्हाट आर द प्रति थ्योरी रो कोन अछि ना, देयर इज every theory is having a background, the how and why the theory has come up, and there is a historical background to that. Who was the person who has devised this theory, what was the basis of his theory, next important feature, what is the basis, what is the principle behind the theory. Therefore then the theory itself, what is the statement of the theory, what it explains. ଏତିକି ସରିଲା ପରେ then how the theory explains about, and then what are the evidences to support to that theory, and what are the basics to which basic inputs which are supposed to explain the theory and its merits and demerits, strength or weakness, and also simultaneously we are trying to know into the critical analysis of the theory, that we can call it as um, critical analysis କହିପାରିବା, କିମ୍ବା we can say that it is a kind of observation on or the criticism on the theory. A type of we can divide. So each theory is going to be divided into a component, that is historical component or the background, historical background to the theory, then the theory itself, then the principle behind the theory, then the description of the theory and its ultimate explanations. Then it comes to the evidences in support of the theory, then critical evaluation of the theory in terms of strength and weakness, or it is the criticism on the theory. ତେଣୁ ଏଇ ଆସ୍ପେକ୍ଟରେ ଆମେ ବର୍ତ୍ତମାନ ଦେଖିବା। ତେଣୁ ଆମର ଯେତେବେଳେ ଫାଷ୍ଟ ବିଫୋର ୱି ଗୋ ଇନଟୁ ଦି ଥିଓରି, ଆମର ଆଉ ଗୋଟେ ଜିନିଷ ରହିଛି ଇଣ୍ଟେରିୟର ଅଫ ଦି ଆର୍ଥ, ଯୋଉଟା କି ଏକ୍ସପ୍ଲେନ୍ସ ଆବାଉଟ ହାଉ ଦି କନଷ୍ଟିଟ୍ୟୁସନ ଅଫ ଦି ଆର୍ଥ ଇଣ୍ଟେରିୟର ୱାଜ ଅର୍ଗାନାଇଜ, କାରଣ ଏଇ ସବୁ ଜିନିଷ ଯାକ ତା ଉପରେ ରିଲେଟ କରିବ ଫାଷ୍ଟ ଅର୍ଡର ଲ୍ୟାଣ୍ଡଫର୍ମ ଅରିଜିନରେ। ତେଣୁ ଆମେ ଯେତେବେଳେ ଥିଓରି ଅଫ ମାନେ ବିଫୋର ଗୋଇଂ ଟୁ ଦି ଥିଓରି, ଇଫ୍ ୱି ଟ୍ରାଇ ଟୁ ନୋ ହ୍ୱାଟ ଇଜ ଦି ବ୍ୟାକଗ୍ରାଉଣ୍ଡ ଟୁ ଦିସ୍ ଆର୍ଥ ଷ୍ଟ୍ରକ୍ଚର, ହ୍ୱାଟ ଇଜ ଦି ଇଣ୍ଟରନାଲ ଷ୍ଟ୍ରକ୍ଚର ଅଫ ଦି ଆର୍ଥ ଇଣ୍ଟେରିୟର। ତେଣୁ ଆର୍ଥକୁ ଆମର ଗୋଟେ ଏଡୱାର୍ଡ ସୁଏସ୍ ବୋଲି ଜଣେ ଜିଓଲୋଜିଷ୍ଟ ଅଫ ଆମେରିକାନ ଜିଓଲୋଜିଷ୍ଟ ହୁ ହାଜ ଡିଭାଇଡ୍ ଦି ଆର୍ଥ and divided the earth into three distinct zones: crust, mantle and core. ଏଇ ଯୋଉ ତିନିଟା division was given by Edward Suez, geologist. ତେଣୁ ଏଇ ଯୋଉ ତିନିଟା କନସେପ୍ଟ, ଏଇ ତିନିଟା ଜିନିଷ ଯୋଉ ବ୍ରେକିଂ ହଉଛି ଆର୍ଥର ଇଣ୍ଟେରିୟରରେ, crust, mantle and core, ଏ ତିନିଟା they are differing from each other in terms of their composition of rocks, characteristics of the rocks, density of the rocks, thickness of the rocks, and then the other properties of temperature, gravity. These are the properties of the rock. So এই অনুসারে differ କରୁଛି. So when it was proposed as the crust is the outer shell that is enveloping the earth's surface, which comes in close contact with the atmosphere. The thickness of the crust is about, on an average, it is about 40 to 60 kilometers depending upon the location. And this crust again comprises of, wherever there are land, it is called continental crust, and wherever there is ocean, it is called as the oceanic crust, because the oceanic crust is below the continental crust. Continental crust ସବୁ ଜାଗାରେ ଅଛି, ଯୋଉ ଜାଗାରେ continental crust ନାହିଁ ଆଉ ocean ରହିଯାଇଛି, ତା ତଳକୁ ରହିଛି ଆମର oceanic crust. Oceanic crust ଟା continental crust ତଳେ ଅଛି, ocean ତଳେ ବି ଅଛି, that is oceanic crust. Oceanic crust ଗଲା ପରେ 40 kilometer 60 kilometer ଯୋଉ ରହିଲା, that is the boundary zone. ସେଇଟାକୁ ଆମେ କହୁଛେ, ମାନେ there is a transition zone between the crust and the mantle. ତାପରେ ଗୋଟେ ପଡିବ transition zone. এই transition zone ରେ କ'ଣ ହୁଏ ନା, the characteristic of the rocks go on differing from the crust and transiting to the mantle, এই ଭାବରେ ଯାଏ। ତେଣୁ ଆମର crust ର characteristic ହେଲା କ'ଣ, density of the rock is about 3, and materials are lightweight, mostly sand, silt and clay, and this type of minerals which are mostly associated with the, and some of the igneous minerals are also available on the crust, and mostly this is the low density rock materials, rocks and minerals which are available on the crust. Then a crust ro ତଳକୁ ଯୋଉ ରହିଲା oceanic crust is little basaltic in nature, eta granitic in nature, outer crust. The inner crust by oceanic crust, that is basaltic in nature, more dark in color. Composition of rocks are more granitic, more basaltic oriented, means high dark content minerals which are available in the igneous rocks. They give a dark tone to the rocks, so they are gabbros and basalts and diorites. Is जो type of rocks हो जाएगा देखा जाए oceanic crust, which is more in density than the crustal rocks. Then crustal rocks 3 density ହେଲା ବେଳକୁ ତା density 4-5 ପର୍ଯ୍ୟନ୍ତ ଯାଏ। ତେଣୁ ଏଇ ଦିଟା ସରିଲା ପରେ ତାପରେ ଯୋଉ ଟ୍ରାନଜିସନ ଜୋନ୍ ଆସେ, ସେ ଟ୍ରାନଜିସନ ଜୋନ୍ କୁ ଗୋଟେ ନାଁ ଦିଆଯାଇଛି, that is what is called the Mohorovicic discontinuity, named after one of the USSR geologist, Moho, his title was Moho. So according to his name, the boundary zone has been given the name Mohorovicic discontinuity. So this discontinuity is the transition between the mantle and the crust. So this is the place where the continental crust rocks slowly change over to the mantle rocks. The mantle rock when it is solid, both the crust is solid, both on the outer crust and the inner crust, they are solid in nature. But when it comes to the oceanic crust, it is more basaltic in nature, and the materials are in a viscous physical state. That means it is like pitch or alcatraz. It's a kind of there is a kind of mobility possible when it is hot. When it is cool, this is behaving like a liquid. So this is how the property of it is neither a liquid nor a solid. So that is a stage, that is what is called viscous stage. So the mantle is about 2,900 kilometers. Up to that, it is extending from the crust to 2009 kilometer ପର୍ଯ୍ୟନ୍ତ ଲମ୍ବିଛି। ଏଇ ଯୋଉ 2009 kilometer ରହିଲା mantle, and it is viscous in condition. Our density is about 5. Temperature goes on increasing very high in the mantle, for which the rocks are almost going to be in a semi dissolved and semi we can call it semi-solid condition. We can call it as a semi-solid condition. The melting, halfway melting, this is what is the situation. And the temperature is about 3000 to 4000 degrees Celsius. Gradually it goes on increasing from the crust towards the core part of the mantle. So like this, the mantle behaves like a viscous material surrounding the entire globe below the crust of the earth. And from there, if we are going towards the interior of the earth, towards the core, then we are getting the core of the earth. And that is what is the core, which comprises of two zones. Gote hala inner core, gote hala outer core. Outer core is in contact with the mantle. Mantle and the outer core, again there is a transition between that. And that transition is also called as one of the discontinuities. ତେଣୁ ଏଠି ରହିଛି ମୋହ discontinuity, ସେଠି ରହିଛି Gutenberg discontinuity. So this discontinuity is between the mantle and the core. Therefore, gradually the outer core rocks are to some extent behaving like a liquid. It is behaving like a liquid, but the inner core rocks are behaving like a, these are now ଯେତିକି ରହିଲା up to 5,600 kilometers. 5,400 kilometers is approximately the radius of the earth through 2,900 ପଳେଇଲା ପରେ ଯାହା ରହିଲା ସବୁତକ, that is a part of the core, and the outer core is liquid and the inner core is solid. And the rocks between these three distinct zones, crust, mantle and core, is crust is Cl. It is called as silicon and aluminum related compounds, mostly dominating silicon and aluminum, so it is called as the Cl. And then the mantle is dominated by Sima. Sima means silicon and magnesium. So magnesium gives a little darker tone to the rocks. And then the core is coming in the name of Nife, N-I-F-E. Nife means Ni stands for nickel, Fe stands for iron. So Nife means these are the predominant minerals available in the core, and the density of the core rock is about 11. So 3, 5 and 11. This is how the density differs. Thickness, as we know, 40 to 60 kilometers up to 2,900 kilometers, and from there up to 5,400 kilometers in the core. And the crust, outer crust is mostly predominant with aluminum, silicon and aluminum compound rocks. So that is what is also sometimes called as the clay minerals. So it is predominant with the clay minerals. And igneous rocks are also there, but granitic in nature. But when it comes to the mantle, it is about the composition of silicon and magnesium. But these are the two index minerals, but there are many other minerals which are also associated with this mantle, and they are mostly giving a dark tone because of the dark color minerals are available more, and then the conditions of temperature allows the mantle to remain in a viscous state. Coming to the core, outer core is behaving like a liquid, and inner core is behaving like a solid object, and the characteristic composition is nickel and iron. And because of the presence of the nickel and iron at the core of the earth exhibits a kind of magnetic property because the iron is a magnetic substance. So what is going on there is some kind of dynamic motion is going on inside the outer core, and that outer core provides a kind of heat and the motion which is the it allows the earth's interior to behave like a thermodynamic situation, just like a static electricity generation from a generator. So it behaves like that, and because of the iron and nickel, which are the magnetic property bearing rocks, the earth attains a magnetic field. So that is how Earth's magnetic field is being defined depending on this property of this. And the temperature is almost about the temperature of the sun because it has come down from the sun in a gaseous state. So the very core temperature of the earth is almost close to the temperature of 5400 or something like near about 5000 degrees Celsius is the temperature at which the inner core is located. So this is what is the temperature characteristic, compositional variation, thickness constitution, and the transition between the cost and mantle and the core. But the question is how people could able to know this thing that this is how the earth's interior is there. This has come from a source of knowledge. Initially, people thought that probably they can dig a hole to the earth's interior and can find out. So that is how Moho, the scientist, he wanted to draw a tunnel inside the Earth's crust with a hope that if it's entering at some point in the sphere, it will be come out at some other point and it will go according to the depth from the surface and try to measure the temperature and characteristic of the rocks and the composition of the rocks, and like this he will try to, but he did that for about 20-25 kilometers of tunnel, and then it becomes very difficult for him to maintain the tunneling because of the high temperature and the high density of the rocks, and the project was abandoned. So this is how nobody knows what is there inside the depth. Then second class of information came from the oil boreholes because oil boreholes dig about 300-400 kilometers depth inside. So it provides the types of rocks which are available from a depth of about 3 to 400 kilometers. That means it is almost collecting the samples of the mantle rocks. So that is how crustal rocks and mantle rock composition to some extent are established through the samples which are coming from the oil drills, which are there in different parts of the globe. Some of the samples which are collected from the drills are experimented and then identified for different type of composition of the minerals. But nobody could able to know the core because nothing is possible to find out the core. The third set of evidence that came is when these meteorites had fallen over the Earth's surface. What is the because meteorite is also a celestial body, like but a smaller feature than the Earth, but they have come down to the Earth's surface, which are the part of the ancient uh, Big Bang explosion from which these particles have been collected, and then they are now falling onto the Earth's surface and entering into the Earth's gravity and then falling on the surface, and then those rock samples were experimented, studied to find out what can be the composition of the rocks. So that provided some clue towards understanding, and subsequently we have a large number of missions, lunar missions, through which a number of samples of rocks have been collected to study what the type of rocks are there in the moon surface, because moon is a part of the earth formed from the, it is a satellite that has formed from the earth during the formation of the solar system. So keeping in mind that yes, this also carries the similar kind of materials which are available in space at the time of formation. So accordingly, people started looking at that yes, earth's composition must be also in the interior, maybe like this. So this is how the kind of explanation collections or the evidences that they try to understand was not complete at all to know what is the constitution of the Earth's interior. But ultimately, the science that came to explain is the study of earthquake waves, propagation of earthquake waves, or seismology. The science of seismology lastly provided a complete information to the Earth's interior. What this seismology indicates is about the interior is seismology means it is a kind of earthquake waves which are created during the earthquake, and these waves used to travel across the globe to different parts, and they are observed across the seismographs which are located in different parts of the globe. It is just like when you throw a stone into the pond, the waves start propagating from the pond towards the shore. Similarly, also the earthquakes, when they generate the earthquake waves, these waves start moving here and there towards the surface of the earth. And when they reach to the surface and wherever there are instruments, seismographs, these seismographs used to record. So, but what is happening is, because the place of the origin of the earthquake, and at different distances there are different seismographs are there. So what they are doing, they are trying to calculate that to reach at Tokyo this much of time, to reach at New York this much of time, to reach at Delhi this much of time, to reach at Bhubaneswar this much of time. So this is how quite a number of observations, when it was observed in the different seismographs, they try to interpolate this data by computer to find out what is the relative position of the epicenter of the earthquake. And that is how they try to know the travel time, and then from the travel time they try to establish the epicenter, and from the epicenter they can take out the focus, where is the focus, and then they bring the news to this public that yes, the earthquake has occurred at a particular depth of this much, 100 feet depth, or 1 kilometer depth, or 5 kilometer depth, at so and so point on the earth's surface. So this is how the news comes. But these earthquake waves, when they start moving, there are three types of waves have been noticed very significantly to indicate the Earth's interior. There are three types of waves: primary waves, secondary waves, and tertiary waves. These are the three types of waves. And these three types of waves, they move in three different ways through the different materials that is available with different density and different temperature and different composition. P waves are the surface waves. They move on the surface with a compression and dilation characteristics. And then S waves are the secondary waves, which is again a type of dilation and compression that goes laterally. So this is another type of wave. And then L waves are the primary waves. So L waves, P waves are the primary waves. S waves are the secondary waves. Then L waves are the surface waves. So these L waves are of the two types also. There are different literatures indicate about Rayleigh waves and L waves like this. But let us understand at the beginning, it is P, S and L wave. And then three waves have three distinct characteristics to indicate. Because in the laboratory they have been experimented that if a P wave travels in a rock material of different density, how it travels and what speed it travels. If it is traveling in a water medium, then at what speed it travels. Similarly, S wave when starts moving inside the solid rocks, how it moves. Then inside again liquid, how it moves. And that is how. And L waves also in a similar way has been. But L wave always moves on the surface, so it has nothing to do with the interior Earth. So for the interior of the Earth, secondary waves are very important, because secondary waves, when they enter into the Earth's surface along with the primary waves get into the from the crustal part, enters into the mantle, and then from the mantle it enters into the core, and crossing the core it emerges outside wherever possible. But S waves, when they start moving, when they encounter the outer core, they are not capable of penetrating the outer core. They got deflected from the outer core and are being observed in the seismographs, but on the opposite side of the epicenter, S waves are not visible. So you will not find the S waves being recorded in the seismographs, which are positioned just opposite to the epicenter, crossing beyond the outer core. And the property of the outer core is that is how it is being identified as liquid, because liquid is a medium where S waves gets absorbed. So it is not appearing on the other side of the liquid. So that is how people could able to know that yes, this is where the outer core is liquid in form, for which S waves are getting absorbed, not visible in that zone when it is crossing the liquid zone. So this is how the seismology has contributed our knowledge to the understanding of the Earth's interior, and along with this movement of the waves based on the laboratory experiments, they have tried to also estimate in what rock composition, at what speed, in what rock density, at what is the speed of this waves transmission. So all these things have been theoretically experimented in the laboratory, has been tested to a real situation, and try to assess based on that to identify that this is what is supposed to be the Earth's interior and the constitution of the Earth's interior. This is how the theory explains about the Earth's interior. And then on this Earth's interior, the next question that comes is the theory of isostasy. So isostasy theory explains about how different
Sir,
landforms on the Earth's surface.
hello, sir.
Yes.
Good afternoon, sir.
Good afternoon.
Sir, ଆପଣ ଯୋଉ କହିଲେ ଯୋଉ inner core ହେଲା ଯୋଉ solid, ତ sir ଏତେ temperature ଆଉ pressure ପରେ ସେଟା solid ଆଉ ରୁହେ କି sir?
टेम्परेचर बहुत अच्छी किंतु जेहेतु प्रेशर बहुत अच्छी तेणु मेटेरियल कोड बाहर चांस नहीं बाहर को. So it is compressed and remaining inside. तेणु टेम्परेचर भी बहुत अच्छी किंतु से टेम्परेचर होला पर से मेल्ट हो जाता किंतु जेहेतु प्रेशर भी बहुत अच्छी तेणु ये गोटे सॉलिड स्टेज रे रहउची.
Sir,
This is what
ସେଇ
it is.
ଯୋଉ pressure sir outer core ଆଉ mental ପାଇଁ ରହିବନି କି sir?
That कम
ସେମାନେ
रहउची.
କେତେ solid
हां that pressure is gradually increase कर जाउची ना towards core. तो जेति जो ट्रांजिशन लेवल रे रहउची प्रेशर, the pressure which is available at the core at a depth of more than 2,900 kilometers is allowing the materials to remain in that stage in a form of almost behaving like a solid. ଆମେ ଯୋଉଟା କହୁଛେ absolutely solid ବୋଲି ସେଟାକୁ ଆମେ ଏମିତି ଭାବରେ କହିପାରିବା it is behaving like a solid and the outer core is behaving like a liquid and the mantle is behaving like a viscous material. ये ହେଲା तार property. It is not absolutely liquid like water or it is not absolutely liquid like alcohol. ଆମେ ଯଦି ଭାବିବା ଯେ ସେମିତି alcohol ଭଳିଆ liquid ହେଇଥିବ କି ପାଣି ଭଳିଆ liquid ହେଇଥିବ, that is not the characteristic. Characteristic is the materials which are there are in a physical state which behaves like a liquid. They are the property.
like sir plasma state?
To some extent, not exactly, but to some extent.
Yes sir.
ଆଉ ତାପରେ ସେଇ ଯୋଉ ମାନେ ଷ୍ଟେଜ ରେ ରହିଲା ସଲିଡ ଆର୍ଥ ର ଯୋଉ କୋର that also behaves like a hydrostatic ମାନେ ସରି ଆମର ଡାଇନାମୋ ଯୋଉ ପ୍ରପର୍ଟି ଅଛି ଡାଇନାମୋ ଯୋଉ ଆମର ଇଲେକ୍ଟ୍ରିକ କରେଣ୍ଟ ଜେନେରେଟ ହୁଏ କଣ ହୁଏ ଗୋଟେ ମେକାନିକାଲ मोशन हुए मेकानिकल मोशन रू कन्वर्ट इलेक्ट्रिसिटी डेवलप हुए.
Mechanic to electricity.
हाँ बर्तन अर्थ कोर भी बर्तन exactly behaving like that because of the temperature and the pressure it is behaving like that and that is developing a magnetic property which earth is exhibiting. So earth behaves like a magnet because of this inner core behaving like a solid with rich iron and nickel minerals. This is what is the background. So ଯଦି ବହି ଟିକେ ଦେଖିବ ଆଉ ଟିକେ you will find little more of details ଆଉ ଯଦି ଟିକେ ଆଉ ଅଧିକ further explore କରିବାକୁ ଚାହିଁବ you will find many interesting things about the chemical reactions and the temperature variations and pressure variations. Exactly କେତେ pressure, exactly କେତେ temperature, ତାର reaction ରେ କଣ ହଉଛି, what is going on inside the because that is a stage which is still representing the sun's internal characteristics. It has come from a big bang and big bang is a celestial body of gases which has been cooled down, but in the process of cooling heat has been stored in the center and outer cells have been cooling down. So this process is also going on still now, it is also going on and the cooling process is still continuing. That is how we get the cracks over the earth surface. Our earth surface which cracks was developed is because of a kind of cooling which is shrinking the crust gradually. Then yeah, this is what is the situation. So coming to the time कम अछि तेणु मु ଟିକେ fast जाउछि तेणु केतोडे skip करूछि. I am obviously skipping many things. କିନ୍ତୁ ଆମେ ସବୁ ଜିନିଷରେ ଟିକେ ଆଇଡିଆ ହେଇଗଲେ କଣ କି ତମକୁ ପଢିବା ଅଣ୍ଡରଷ୍ଟାଣ୍ଡିଂ ରେ ଡିଫିକଲ୍ଟ ହବନି ନହେଲେ କଣ କି ପଢିବା ମେଟେରିଆଲ ବେଳକୁ ଟିକେ କନଫ୍ୟୁଜନ ରହିବ ତେଣୁ go with this ସବୁ ଜିନିଷ ଟିକେ ଟଚ୍ କରିଦେଇଥିଲେ it will be easy for you to have a clear understanding of the things while reading the study materials. Okay.
Yes sir.
So we are coming to the isostasy, theory of isostasy. theory of isostasy explains about how the different landforms over the Earth's surface are in a hydrostatic balance on the mantle. Because ଆମର ଯୋଉ crustରେ ଯୋଉ ବିଭିନ୍ନ ପ୍ରକାର rockର exposition ଅଛି, କୋଉଠି mountain ଅଛି, କୋଉଠି plateaus ଅଛି, କୋଉଠି plain ଅଛି, କୋଉଠି oceanic crust ଅଛି, ଏ ସବୁ ଯାକ mantle ଉପରେ rest କରୁଛି। ଆମେ ସିନା Earthକୁ କହିଦଉଛେ, we say that Earth is a perfectly sphere, but it is not a perfect sphere, it is a spheroid. Even it is not a spheroid, it is a geoid, where the Earth's variations are varieties on the crust with the crustal rocks. Then that is how somewhere the crust is rising to 10 kilometers, like somewhere the crust is also going much below, about 10 kilometers of depth inside the sea or more than that. Then ଏମିତି ହେଇକି Earthର surface ର configuration ଯାକ ଏମିତି ସବୁ ରହିଛି. It is not a very plain surface like a ball. It's a very irregular surface. So the irregular surface ରେ somewhere the land, somewhere the continent, somewhere the mountains ର ରହିଛି କ'ଣ? ତେଣୁ ୟାକୁ study କରିବା ପାଇଁ ଦି ଜଣ scientists, one is Aries and one is Pratt. ଦି ଜଣ scientists, they try to study this particular behavior of the Earth to find out what is the kind of balance. So they try to find out ଗୋଟେ ହେଲା theory of compensation, ଆଉ ଗୋଟେ ହେଲା theory of uniform compensation, ଆଉ ଗୋଟେ କ'ଣ theory ମୋର ମନେ ପଡୁନି exactly, the Aries theory, equal level of disposition within the crust and the ମାନେ below the crust and above the crust, এই ଦୁଇଟା ଜିନିଷ ତା ଭିତରେ explain କରାହେଇଛି। ଗୋଟାକରେ explain କରାହେଇଛି in Aries theory, it is explaining that all the continental rocks which are above the surface, they have also equally that amount of root zone inside the mantle. It is just like when ice floats in the water, floats over the water, one part remains above, 9 part remains below. সেই condition ରେ ice float करे, and exactly earth ର जो crustal materials ଅଛି ସେ ଯାକ ବି ସେମିତି ଗୋଟେ mantle ଉପରେ ସେମିତି ଭାବରେ float କରୁଛି, as if we consider that a portion of the earth's crust, it is having a very high altitude, the root is also very long inside, and if the crust is very low in thickness like the oceanic crust, the root zone is also not very far, it is very close to the mantle. So that is the proportionate distribution between the crustal rocks above the sea level and above the crust and below the crust. This is how, so you can imagine that Earth has been divided into several blocks. Ita kahinki asila, the very historical background to this is British time thila, when Everest was the Surveyor General of India. ସେହି ସମୟରେ ସେମାନେ ଯେତେବେଳେ ଇଣ୍ଡିଆକୁ ମ୍ୟାପିଂ କରିବା ପାଇଁ ଆରମ୍ଭ କଲେ, ସେତେବେଳେ ଗୋଟେ ଜିଓଡେଟିକ୍ ସର୍ଭେ କରିଥିଲେ। they made a geodetic survey to start the survey for computation of the maps, ଆମର ଯୋଉ topographic maps ସବୁ ତିଆରି କରାହଉଥିଲା ସେହି ସମୟରେ ବ୍ରିଟିଶ ଟାଇମରେ, they started doing this। ସେହି ସମୟରେ ତାଙ୍କର ଯୋଉ ଏକ୍ସପେରିମେଣ୍ଟ ଚାଲିଥିଲା, they found a differential gravity of attraction between their observations at some point in ବିହାରର ଦିଟା ଜାଗାରେ ସେମାନଙ୍କର ଗୋଟେ ଦେଖିଲେ ଯେ ଯେତିକି amount ର deflection ଦେଖେଇବା କଥା ସେତିକି amount ର deflection ଦେଖଉନି in their experimentation, because the reason they found out that Himalaya is very close to that। କିନ୍ତୁ ଯଦି ହିମାଳୟ ଛାଡି ଦେଇକି ସେ ଜାଗାରୁ ଯାଇକି ଆଉ ଗୋଟେ ଜାଗାରେ କୋଉଠି ଯଦି କରାଯାଉଛି far away from Himalayas, the nature of deflection is different। ସେଇଥିରୁ ସେମାନେ ମାନେ derive କଲେ that probably the large masses of the large bodies of the crustal blocks which are there, they are also exerting a pressure on the nearby substances and nearby materials। ତେଣୁ the behavior of the crustal rocks are like this। ତେଣୁ ଏହାକୁ ସେମାନେ relate କରିକି gradually they have come down to a conclusion, and that has led to the theory। ତେଣୁ Aries theory ର explanation ହେଲା, the crust is composing of a number of blocks, we can imagine in the form of number of blocks। ମାନେକ ଗୋଟେ ହେଲା oceanic block, ତେଣୁ ତାର thickness below this mantle is low, but when there is a mountain like Himalayas, the root zone is very deep। Each type ro, so there is some part remains above and some part remains below, and there is a hydrostatic balance of all the landforms, was the conceptualization of Aries। Into the another concept was also brought down simultaneously opposing to the Aries theory, was given by Pratt, when he thought that because the density of the materials are different and there is a uniform compensation level, he thought of that ଆମେ ଯଦି ଏମିତି ଗୋଟେ zone କୁ ବାହାର identify କରିଦେବା in the mantle where all the rocks are over that zone and the pressure exerted on this is equal, and if there is a high rock mass, it is supposed to be low density. If it is a low rock mass, it is supposed to be high density, so that the pressure at the level of compensation is remaining same, and all the features are in a static balance between the mantle and the crust. ତେଣୁ ଗୋଟେ ହେଲା ଭେରିଏବଲ ଥିକନେସ୍ ଆଉ ଗୋଟେ ହେଲା ୟୁନିଫର୍ମ କମ୍ପେନସେସନ ଲେଭେଲ। ଏଇ ଭାବରେ ସେମାନେ ଆର୍ଟସର କନଷ୍ଟିଟ୍ୟୁସନକୁ ଆଇଡେଣ୍ଟିଫାଇ କଲେ। ବୋଥ ହାଭ୍ ଏ ସିଗ୍ନିଫିକାନ୍ସ ଇନ୍ ଦେୟାର ଅଣ୍ଡରଷ୍ଟାଣ୍ଡିଂ। କିନ୍ତୁ ଏ ଦିଟା ଯାକ ଥିଓରି ବି ଏମିତି କିଛି ଗୋଟେ ମାନେ ଇଟ୍ ଡଜଣ୍ଟ ଲିଡ୍ ଏନିଥିଙ୍ଗ ସିଗ୍ନିଫିକାଣ୍ଟ ଟୁ ଦି ଫ୍ୟୁଚର। କାହିଁକି ନା ଦିଟା ଯାକ ଥିଓରିର ଲିମିଟେସନ୍ସ ବହୁତ ରହିଲା। ଦେयर ୱାଜ ଅ ଲଟ୍ ଅଫ୍ ଲିମିଟେସନ୍ସ ଅଫ୍ ଏକ୍ସପ୍ଲେନିଂ when the theory of plate tectonics totally changed the idea of all these things. ତେଣୁ ଏ ଦିଟା ଜିନିଷ ଏମିତି ଇନିସିଏସନ ହେଇଥିଲା, ବଟ୍ ଫର ସମ୍ ଟାଇମ୍ ପିପୁଲ ଥିଙ୍କ ଅଫ୍ ଲାଇକ୍ ଦିସ୍। ୟାର କିଛି ଦିନ ପରେ ଦେନ୍ ଫାଷ୍ଟ ଅର୍ଡର ଲ୍ୟାଣ୍ଡଫର୍ମକୁ ଷ୍ଟଡି କରିବା ପାଇଁ ଆସିଲା theory of continental drift. This continental drift theory was devised by Alfred Wegener, a German meteorologist. He was a German-born meteorology scientist, and his theory came out of his experimentation which he was doing in the polar area, north polar area रे तांकर गोटे experiment project चलथिला, जो project रे he was trying to study the impact of climate change, evidences in search of finding out the evidences for the climate change with a hypothesis or with a basic presumption that the climate of the earth has changed, and if the climate of the earth has changed, so according to the climate, the distribution of plants and animals must have changed, distribution of the coal deposits must have changed, distribution of the coral reefs must have changed, because they grow and they come up, they flourish in a particular temperature and climate environment. And now if we find such type of fossils in a different environment, so obviously it means either the materials have shifted their position or the earth has shifted their position. So this is the basic consideration in which he was experimenting in the North Pole area to find out evidences of the climate change. And his assumption was, जदि हमें वर्तमान कोल पाउचे नॉर्थ पोलर एरिया रे, like Iceland, like England, जदि हमें कोल पाउचे which is a temperate zone, but we know very much that the temperate forests do not contribute to the formation of the coal, rather it is the equatorial forest which undergoes subsidence and then submergence and then packing within the materials, and then in course of time the carbon it gets converted into carbon and coal formation takes place. But if we are finding those things in the temperate zone or in the polar zone, obviously it means se jaga ko koila asila kemti, se jaga ko sei type ro equatorial forest asila kemti se jaga re, ta mane se jaga re kebe bodhe nischay equatorial climate thila kimba e jaga ta equator re thila kebe ethi transfer hei pole as shift hei. So these data condition ku he was trying to validate with the evidences. So eku study kori last he came to a conclusion that continents have drifted. It is not that climate only has changed, climate has changed, and simultaneously continents have also drifted from their position, original position. Through the passage of the geological history of the earth, the continents have changed their position. Then he started looking at the evidences. How can evidence मिलिबो to explain that continents have drifted? Then he looked at the third most important evidence. Project information then he started looking at, like a advocate, he started looking at finding out what can be the evidences. Mind with jigsaw fit of the North and South Americas with the Europe and Africa. Jigsaw fit. If you look at the eastern side of North America and South America and the western side of Europe and Africa, देखियो अफ्रीका रो जो बल्स टा वेस्ट साइड को अछि आ नॉर्थ और साउथ अमेरिका भीतर जो गल्फ ऑफ मेक्सिको अछि से दिटा रो शेप पाखा पाखी समान हे जाउछि आ साउथ अमेरिका और अफ्रीका दि जाको मिसि जिवो यूरोप और नॉर्थ अमेरिका मिसि जिवो एज इफ फ्रॉम ए लाइन ऑफ सेपरेशन both these blocks have separated from each other. So it is a kind of matching of both sides of the North and South Americas with the matching of the Europe and Africa's coastal configuration and the shape initially struck to his mind, which normally one cannot visualize. Visualize but he visualized that yes, it may be possible. Then because he was a climatologist, then he tried to also started looking at geological evidences to look for the climate. Then he started assessing the geological evidences in relation to climate and distribution of plants, flora and fauna. जदि या हेइथिबो जदि कॉन्टिनेंट जाक जदि सेपरेट हे जाइथिबे गोटे लाइन रे अमेरिका और साउथ अमेरिका जदि गोटे जगह रे सेपरेट हे जाइछन्ती गोटे जगह रे मिसे की थिले से पाखपाखी समान होउची ताले दी साइड रे रॉक समान हबार चांस अछि there must be similarity of the rocks, similarity in the stratigraphy of the rocks, similarity in the fossil composition of the rocks, and similarity in the distribution of rock on both the sides. Then he started looking at these evidences. So he started collecting evidences in support of this, and also he became successful in finding similarities on both the sides of the coast, and also find a lot of geological similarities, geological fossil evidences on both the sides matching to each other, implying that MT possible it may be a possibility that the crust has broken and the North South Americas must have shifted. So this is how he started looking at the third important evidence. Then fourth evidence came to him looking at the distribution of the glacial ice sheets and the evidences of old glaciation. ଯେତେବେଳେ Earth ରେ cold climate prevail करे से समय the glaciers used to extend far beyond the polar area up to the tropic and subtropical area. ये जिनिसटा ହେଇଛି ଆଗରୁ. There has been many times Earth has passed through the phases of coldness. जो समय कि the glacial ice which is now limited to North Pole and limited to South Pole and Antarctica has come extended up to a long distance in up to the about 30 degree 40 degree পর্যন্ত भी আসিছে. There are evidences, and you will be finding a peculiar evidence that our part of present Odisha's Talcher bearing coal fields also provides the evidence that there has been glaciation in the past during the Carboniferous period. Carboniferous period रे glaciation रे Talcher area रे glacial evidences वर्तमान मिलुची. So that implies that this particular area was a part of Africa, and it was also part of the submerging glacial ice of the South Pole. South Pole रो glacial ice ये पर्यंत तालचेर पंद लंबितला. तालचेर जेतेबेले अफ्रीका सहित लागिकी थिला. India block was attached with the African landmass, and there has been distribution of flora and fauna across different parts of the globe, where he found that cold climate species are available now in a hot climate. So that evidence has also indicated that the drifting has been responsible for okay. Rama, আসছুকি? ଆସିଛି ଦେଖିବୁ ନା ନା ଆଉ ଟିକେ ଡେରି କରି ଆସ ନା ଆସିବୁ ଯଦି ଆସିକି ଦେଖିଯା ଆସିକି ଦେଖିଯା ମୁଁ ଅଛି ଘରେ ଆଉ ତୁ ଆସିଲେ ଆଉ ଟିକେ ଡେରି କରି ଆସିଲେ ଚଳିବ ଠିକ ଅଛି ହଁ ହଁ ଟିକେ ଡେରି କରି ଆସ ଚଳିବ okay sorry for the interruption. So this is how he started gathering a lot of evidences, and then lastly after compiling all these evidences then he put up the theory of continental drift with a statement. The theory statement is Earth was all the continental blocks which are available now across the globe are aggregated at around Africa at one place, having one supercontinent and one ocean. And the supercontinent was named by him as Pangaea, and the surrounding ocean was Anthalassa. And this Pangaea was extending from North Pole to South Pole, and above the equator it was the Angara land, and below the equator the part of the Pangaea was called as the Gondwana land. In the south रो जो रहिला Gondwana land सेइठु हमरो Gond tribe रो नाम भी आसीची, and that has also becoming a part of our Indian bloc. Then this is what is the configuration, and between the Angara land and the Gondwana land there was a Tethys Sea, and the Tethys Sea was exactly taking the position of the present Mediterranean Sea, and then extending further towards east, covering parts of Himalayan region up to China. So like this, there was an extensive Tethys Sea, there was Angara land, there was Gondwana land, and Pangaea was there, surrounding it, Panthalassa was the sea. And this was there up to the, because in geological eras, we have tried to know that life has not started, life started coming in the Paleozoic era. Beginning of the Paleozoic era, life started appearing in the form of unicellular plants and animals. Till that time, in there, this world was like in a single continent called Pangaea, and it was continuing. So in the Paleozoic era, there are 6 periods. Those 6 periods are Precambrian, Cambrian, Ordovician, Silurian, Carboniferous, Devonian. These are the 6-7 periods that is a part of the Paleozoic era. So it is about 250 million years total. This, and this during this period, halfway in between, when the Carboniferous period was about to coming, so that is the time when glaciations has occurred. So that is the time when the Pangaea started breaking. That was his estimation. And the Pangaea started breaking at that time. And then in the process of breaking, gradually Australia moved towards the eastern side. Antarctica moved towards the southern side from the African bloc. India moved towards northeast direction. Then Atlas Mountain and this European moved little north. South America and North America started moving towards west. So this is how the segregation was initiated, and in course of time, about another near about 100 million years, the present configuration has been achieved. So this is what was the theory of continental drift, that the Pangaea had started breaking, and when he started trying to say that this Pangaea is breaking, he has to explain that why it will break. So it was very difficult on his part, because he collected a lot of evidence to say that yes, there is a chance of breaking, because the kind of evidences are showing that yes, land blocks must have moved, because the evidences are now clear to explain this. But why the blocks will move out? What will make the cracks to open so widely? That what is the force responsible for this? So when this theory was put forth by William Morris Davis, this Alfred Wegener, in the European Union, because he was from Germany, and when he put up in the European journals, there was a lot of criticism to his theory, and most important criticism came to him that what is the force responsible for breaking the Pangaea to such huge blocks? What could have been a force responsible to break this? So that was very difficult on his part to explain. He thought that probably there is a tidal force which is responsible for dragging this North and South Americas away from Africa. And there is a tangential force which was mostly responsible for shifting these three, uh, Antarctica and Australia and the Indian bloc, towards northeast, east, and the south. So this is how he started telling before the scientific community, but this is what is the way that probably things must have happened. Some tidal forces are responsible at the initial stage of the Earth's formation was going on, and that is how the American landmass must have moved towards the west. And he also tried to explain that yes, because of a moving block, the advancing edge always becomes crumpled, so there are chances of formation of mountains. That also he started telling during that theory. So this is how he started explaining, but he was criticized vehemently by the opponents, his contemporaries, that he is advocate, he is telling the theory just like an advocate, as if he is assembling a lot of information to put up something to which there is no science and logic. So that can be because of some other reason, maybe, which we do not know. Because if a force responsible for breaking this such a huge landmass like Pangaea into several pieces, that could have also possible to break the whole Earth into many pieces also. Just like moon has come from the Pacific, similarly many things must have dispersed from the Earth. So theory was not tenable. But it continued for about 100 years, remaining in the earth scientist circle. That yes, till then, when no other theory was there to explain, let us accept that yes, something must have happened, let us look for it. So another group of scientists subsequently started carrying forward this theory of continental drift. That if the things have moved out, then what should have been the reason behind the moving? And is it true that the movement is possible? So what they did is, so at that time, a lot of experimentation was undertaken inside the sea to find out what is there at the depth, how the ocean floors are, what are the properties of the rocks in the ocean floor and in the continents on the submerged mountains. So like this, there were a lot of investigations were carried out, and that is the time when actually this Scripps Institute of Oceanography of California played a very major role, and many of the people, challengers, the name of the ship was Challenger, and the Challenger ship was the experimental ship engaged for this collection of data across the globe. So what they did, they started mapping the depth of the ocean. Till that time, nobody was knowing what is the depth of the ocean at different places across the oceans. So they started measuring the depth of the ocean. Then they started measuring the temperature of the different places inside the ocean, on the surface and on the below the surface, much below the surface. And then peculiarities of depth. So by measuring the depth, they could able to find out where are the submerged mountains, where are the submerged plateaus, where are the submerged plains, so something new emerged, which was not noticed before that. By measuring temperature, they started finding out that why there are certain pockets where the temperature is very high, when there are certain places in the same depth where temperature is very low. So they started finding out also the types of rock samples. They found out some of the rock samples which are very recent in origin in terms of formation. There are some parts of the oceans where the origin of the rocks are very old. So that also they try to ascertain. So all these things made to again map out the configuration of the ocean bottom, where they find out that in the Atlantic there is a mid-oceanic ridge, which is extending from the North Pole to the South Pole, perfectly to the shape of the east and the west coast of North America, Europe, and South America, Africa. So the coast is exactly in the same shape, just like our shape of the continent. And then temperature is very high. There are volcanic islands over the mountain, submerged mountain, and the volcanic materials are also there. And then they started studying the magnetic property of the rocks also, those are the samples which are collected. And magnetic property also indicated that younger rocks are closer to this, and there are periods of rocks which are of particular magnetic behavior, then another will change, then there is another type of magnetic behavior, because magnetic property indicates the magnetic inclination and magnetic polar directions. So all these evidences, when were compiled together across the globe, the people who have been there in the expeditions, out of them, two important persons were Tujo Wilson and James Morgan. They are the two scientists who were there with the mission. They built up this idea of plate tectonics. That the theory that they brought is yes, Earth has been comprising of a number of lithospheric plates which are there over the Earth's surface, and these lithospheric plates are separating from each other across the cracks, joints, or faults, and or through the trenches in the ocean. In the ocean, there are trenches. Over the land, there are cracks, joints, faults. So these are the discontinuities between the plates. And these plates are up to a depth of 100 kilometer inside the crust. Because at 100-kilometer depth, they started estimating that that is the temperature where the rocks which are supposed to be may be in a condition of semi-fluid, allowing the crust to move over or slide over this mantle. So that is they named as the asthenosphere, layer of asthenosphere. So the asthenospheric level was 100 kilometers. So the plates thickness were 100 kilometers, and there are different sizes of plates across the globe. like North American plate, South American plate, Eurasian plate, Indian plate, Australian plate, like this. So, and there are major plates, there are minor plates, like this. They identified and then put up the theory that plates are moving over the Earth's interior like a conveyor belt. When the conveyor belt moves, continents, materials also move out. Similarly, when these are moving, the continents are also moving from one place to the other. That is how they have shifted their position. It is not the drifting of the continents, it is the movement of the plates. So the theory of continental drift just transits, taking the transition of being explained through the plate motions. And by plate motion, they also started telling that yes, over the plates, whatever the continents, they have also changed their position, because when the plate changes, the continents also change along with it. So this is how the plate tectonics theory came before the world, before the earth scientists across the globe. And then when the theory came up, then people started assessing the theory's relevance, theory's significance, theory's scientific possibilities, and three more things also came to support this theory of plate tectonics. What is distribution of mountain systems, plateaus, plains, saddle, and arcs? All these are supporting to this theory. So that is how it came up. Because when plates move, because they identified three types of plates movement. They identified that plates may move horizontally towards each other, or they move away from each other horizontally, or the plates may also slide past each other. One plate may go ahead, another plate may come down like this. This is what is called slide past each other, or some plates moving away from each other, or some plates coming and colliding each other. So these are the three ways in which plate motions are taking place. And by this process, they started finding out that wherever there has been collision of plates, mountain formations has taken place. Wherever there have been places that they have diverged, they have created oceans, they have created ocean basins, and simultaneously when the ocean basins are created, there have been different type of features associated with this. So there are boundaries from where the plates are formed, there are boundaries where the plates are destroyed. So they find out the trenches as the places where the plates are destroyed, getting into the Earth's interior, and the mid-oceanic regions are the places where the plate formations are initiated by the volcanic eruption, lava materials coming up and then sliding down, and by sliding down also pushing the plate to move out. And this is happening along with what is going on inside is a convection current, because of the heat that is preserved inside the mantle is allowing the material to remain in heat, hot stage, and because of that hot stage there is a circulation of heat across the mantle, and this circulation is providing a inertia of things to move the plates, and when the plates are moving on the surface also changes are taking place. So when there is a divergence of the plate, so in the place of divergence there are chances of mid-oceanic ridge, and then there are chances of islands across the ridge, volcanic islands, places of earthquake zones, so like this. And places where this collision of plates are taking place, like Indian plate colliding with the Asian plate, or the American plate colliding with the Pacific plate. So at the collision zone, there have been formation of mountains, or the Australian plate colliding with the Pacific plate on the eastern side. So you find on the advancing edge of the plates, there has been formation of young fold mountains. So all the young fold mountains that they noticed across, along with the plate tectonics theory, when they started looking at which are the young fold mountains, they came to know that yes, Himalayas has been found because of Indian plate collided with the gradually moving away from Africa, collided with the Asian plate. So the Sea of Tethys was folded into the Himalayan mountain system. Similarly, when the Europe started moving towards the Tethys Sea was also transformed into the Appalachian mountain systems. When the America moved towards the western side, the advancing edge of the American plate colliding with the Pacific plate, they started forming the Rocky Mountain system and the Andes Mountain system. When the Australia moved toward the east on the eastern side of the moving block, formation of the Great Dividing Range, that is the Youngford Mountain. So all these mountains are of the same age of near about 10 million years, formed in the Tertiary period. So this is how subsequent developments came up to support to the theory. And then wherever the plates are diverging into the Earth's interior, there are places where the plates are also creating and moving. But where they are going? They are going inside the trenches. If you find the Asian plate is moving toward the eastern side, while moving toward the eastern side, they are getting into the trench. What are the trenches? Along the east coast of Asia, you find right from the Bering Sea, there is Kirill Trench, then Japanese Trench, then Philippines Trench, then Mindanao Trench, then Tonga Trench. Like this, there is a series of trenches. So these are the areas where this Asian plate is gradually getting into this interior, sliding into the. So whenever they are sliding, so one plate is here, but the other plate is sliding beneath. So there are chances of formation of island arcs. So that is how we find a lot of islands across the east coast of Asia, like Japanese island, there is Philippines island, and then so many islands, Elvis Island, and many other islands which are there on the eastern side are because of this. So this is how they started gathering various other kind of informations, and पहुंच ही Oh, just a minute. Hey, बोलो सर रामासी खोल दो. So like this, plate tectonics stated ultimately became a very one answer to almost all questions of earth science. One answer to almost all questions of earth science puzzles, and it became one of the dominating theories to explain all the landform features and their formation. Whether it is a mountain, whether it is an island arc, whether it is a volcano, whether it is an earthquake zone, whether it is a volcanic zone. If you look at the Pacific Ocean, you find the Pacific Ring of Fire. This Ring of Fire is volcanic eruptions going on across this Pacific Ocean on the eastern and western side. And on the eastern side of the Pacific, it is the west side of North America. You find this California Trench and other trenches which are there. So that is the place where this American plate is again subduing into the or entering into. So this is how there are different positions, and in South America again you find the Peru Trench, Chile Trench, and then those trenches which are again the part of American plate getting into the Earth's interior. So like this, quite a number of evidences is supported to the theory, and then ultimately the convection current, which was supposed to be the driving force, because the continental drift theory failed because it could not explain the force responsible for the movement of the blocks. But this was resolved out when the plate tectonics came, because plate tectonics started deriving the information from the motion of this Earth's interior through the convection current which is moving across inside the mantle is responsible for this. So the input also came to explain what is the process of drifting of the continent, this movement of the plates, and then configuration of the first order landforms, second order landforms, which are different positions and places, that is also being explained. The origin of the earthquake and volcanic eruption sites, that was also explained, and the location of the places of mountains and valleys all are also being explained. So ultimately, plate tectonics started ruling the entire earth science for almost near about 100 years now, and this still earth is moving and plates are in motion, and there has been many evidences piling every day to support to the theory that yes, plates motion are going on, and trenches have been active in taking over the plates, and mid-oceanic ridges have been active in creating the plates, and that is how things of acceptance has come to the plate tectonics theory. Okay, then we are coming to previous class we have discussed something about this continental drift. Sorry, the next theories which are important in the landforms is our Daviesian theory of cycloerosion and non-cyclic theory of evolution of landforms by Walter Pang and C.M. King. So what is the peculiarity of these theories? What they are explaining? Because this continental drift explained about the formation of the mountains and continents, oceans and mountains and plateaus, valleys, all this. Then this plate tectonics theory also again explained everything on the Earth's surface, how to explain all these things of a very large features, whether it is a volcanic belt or whether it is a earthquake belt or whether it is a island arc or a group of islands or everything, what are the mountains, positioning of mountains, all these things, and positioning of the trenches, everything was cleared through this. But when it comes to the third order landforms, there has been a way of looking at this, that how to conceptualize a principle or a concept in which the explanation of the formation of the landforms can be explained. Okay, just 2-3 minutes and we'll take a break and coming session. Okay, so we are coming to this third order landforms. So the third order landforms, there was a basic crisis of how to generalize the evolution of landforms, how the landforms to be explained. Because when we are going to study the third order landforms, again the same principle of geomorphology comes into. Geomorphology is the study of landforms, their origin, their classification, and their knowledge for some kind of applications. So we have to study again the origin and then classifications. So how to look into the origin of the third order landforms and how to classify the third order landforms. So that has become one of the challenging issues. So that is the time when William Morris Davis is one of the geologists of USA who put forth a theory that was known as the cycle of erosion, theory of cycle of erosion. He started accepting the basic principle of Darwin's theory of evolution of life that takes place through the youth, maturity, and old age. And youth characterized by a lot of energy to do work, and then maturity characterized by a lot of energy but in a constructive work. And then old age is a kind of energy which is very low and not capable of doing much work, but ultimately passing on to the end phase of the life. Similarly, a abiotic landform or a kind of landform that we are now looking for in the third order features of the Earth's surface, whether it is a mountain or a plateau or a valley or whatever it is, or in a sand dune or whatever the kind of features that we find as third order landforms, can they evolve like this? That they start taking a bath or immerse or they start initiation takes place, then they grow with the energy, high energy, and then the energy comes down and passes to a mature stage, and then it goes towards an old age and a senile stage, and then they disappear from the surface of the earth, losing the all the initial characteristics with which they have been originated. So this is what was the acceptance of the theory of Darwin's life cycle. So his contemporary was this William Morris Davis was the contemporary geologist of his time, Darwin's time. So he also accepted this theory of accepting the Darwin theory, putting forth the theory in the landforms, started looking at that every stage of landform evolution. The landform evolution takes place mostly by different agents across the globe. There are different agents to form the landforms. But he believed at the initial, when the theory was put forth by him, he believed that major part of the Earth's surface is acted upon by the rain. And rain and the characteristic features of rain actually molds the Earth's surface to form different type of landforms. So river is the predominant agent of weathering and erosion on the surface of the Earth to create different landforms. So if this becomes a major agent of landform formation, then can the river create landforms of youth, maturity, and old age? So by exploring this hypothesis, he started coming to a conclusion and putting forth the idea of this cycle of erosion as a theory for evolution of the landforms, where he postulated that in the process of evolution of the landforms, normally a landform appears on the surface of the earth by upliftment. Anywhere on the surface of the earth, if there is an upliftment, then the landform appears on the surface. And that landform unit is acted upon by the rain, overland flow. After the rain accumulates, overland flow takes place, and then water starts moving here and there through the rills, gullies, streams, valleys, and rivulets, and ultimately join together in the form of rivers to pass through that. So that is the beginning of the landform, that is the, you can say it is the birth of the landform, or it can be the beginning of the landform. And after this beginning of the birth, or you can imagination of a landform, and its progress gradually now will take place. It will start becoming a child, and then it becomes an adult, and then becomes an adolescent, then adult. So the phases will go on. Similarly, the landform will also go on changing in a way that because it is uplifted from a sea level to a higher altitude, obviously the gravity of the landscape, the slope that it is available to the landscape, is playing a primary role in taking out the agent river to flow. And by this, the valleys are created. And after the valleys are created, then the valleys start widening, valleys start deepening, valley starts deepening, valley starts widening, and then after widening, there are two valleys, they join together and form large valleys. So like this, slowly the changes are going to take place, and the slopes on the surface of the also, that area is also likely to go on declining, because slopes will decline gradually. So if you think of a triangle, mm, the triangle can be a similar shape, but can be a triangle of a larger one, then it can be a smaller one, then it can be still smaller one, but the slope remains constant. Is one way of change of the triangle from a large triangle to a small triangle. But there is another way of a large triangle coming down to a small triangle. Suppose there is a triangle like this. Then gradually the triangle will go like this, and then the slope will go on changing. And then the peak is like that, but at the end of the stage, the peak will be like this. But in the initial stage, the peak was like this. Then the peak was again smaller, but like this. Again, the peak was smaller, but like this. Same. But in these two situations, what is happening? In one situation, the slopes are remaining constant. The size changes, but the slopes remain constant. In another triangle, the size changes, but simultaneously slope changes. So there is a, when the size is changing, but the slope is maintaining, there is a peak. Even if it is a small hillock, there is a peak. But here, there is no peak, it is mounted. It is a mound. It is a truncated surface on the ground. So this is how the two landforms develop in two different ways. This is a conceptualization. So Davis believed that the second one. Davis believed that all landscapes on the surface of the earth has to go on a change. How the change will take place? So initially, if there has been upliftment and rivers are flowing, vertically cutting, a landmass is isolated in the form of a mountain, and now this mountain has to also undergo weathering and erosion. So what will happen? It will be like this, then it will be like this, then it will be like this, then it will be like this. So ultimately, it will come to a plane like this. So this is what is a kind of conceptualization of Davis. That is what is called slope declining process of landform change. And during the early stage of the child stage of the landform, early stage we can call it, the landforms exhibit a very rugged, different type of differential topography, differential relief. But this relief becomes maximum gradually with valleys cutting by the rivers in a very steep way. They will find the steep gorges, steep V-shaped valleys through which the rivers will be flowing. So like this, the rivers will be in the initial stage of the land block, will exhibit the characteristic of V-shaped and parallel valleys, gorges, large waterfalls. When they will come down from one height to another height, they will form waterfalls. Then within the valley also you will find large number of boulders will be sliding down, um, and there will be boulder beds on the river. The water will be passing between the boulders. So this is how there will be formation of rapids. A lot of rapids will be there, then water will be jumping like this over the rocks and then moving. So you can imagine that in a mountainous track with a lot of boulders on the river bed, the river water will be passing through the boulders. So this is what is the situation. And these boulders will be slightly rolling down from the upper part of the river towards the lower part of the river, breaking the rocks at different places, and then creating a kind of effect in just dredging the river valley in a V shape. And the climax will reach in this youth stage when it will be transiting towards a mature stage. That is, the stage will come when the ultimate maximum depth of the river has attained and the maximum depth of the peak has come down. So peak was this much, it has come down here. Depth was here, depth has gone like this. So the difference between the highest point and the lowest point in the valley itself is called the relief. So the relief becomes the highest in the maturity stage because in the youth stage, the peak is here, the valley is here. But in the mature stage, what has happened? Peak has come down and some materials have deposited on this, and in the process, the relief becomes very high. So relief becomes low in the initial stage, relief becomes high in the middle stage when it is mature stage, because that is the stage of constructiveness of the river in formation of valleys. So valleys will be transforming from the youth stage to a mature stage. In the mature stage will be coming, the river will have a type of landscape where the river will swirl around, hydraulic action will predominate, river will take its turning like a meander within the valley. So meander is not a meandering course like this. The river is moving like this is not meander. This is meandering also, but that's not a kind of meandering I am talking. I am talking about that this is the valley, and within this valley the river meanders because of the hydraulic action. So this is what is something different. But there can be a meandering course of the river depending on the structure on either side. So there is a control, river cannot flow, so it will have to go like this. Then there is a control, it has to go like this. Then it has a control like this. So this is what is also type of meandering. But this is a structural meandering. But hydraulic meandering will be that within the valley there will be river and the river will be flowing like this. So this is what is a kind of youth stage to transforming to a mature stage of the development of the river with wide floodplains, river valleys, and on either side you will find the levees, longitudinal bars, transverse bars. There will be pools and riffles within the river valley. Pools means when the water will be coming in from the upper reach with high speed, the water will fall like this, will create a groove in the valley. That is what is called pool. And when the water will lift from the pool, it will take the sediments, will deposit somewhere. Then it becomes a riffle. That means the water will be going like this. So in the river, normally we see that water is moving like this. But on the actual floor, the water is moving like this with pools and ripples depending on the topography of the floor. So this is the way in which there will be different type of features will be creating, which are indication of a mature stage of a river, and then will come to a old age of a river. But in course of time, when he started thinking of that, if he is explaining only for the rivers, he is not going to suffice the entire theory to fit into the areas where the glaciers are there, where the oceanic waves are there, where the groundwater is there. So these are the things which he encountered. So then he modified his the same theory. Initially, his cycle of erosion theory was modified that wherever there are glaciers, it is a climatic modification of the agent of weathering and erosion. That means the river water which was there has now converted into glacial ice because of the cold temperature situations. So this is where the problem is to accommodate. And whenever there is a desert condition where the water is not available and wind is predominant, then wind becomes the predominant. These are the climatic accidents on the Earth's surface. If 70% of the area is under the rain, domain of the rain, another 20-30% of the area is domain of the glaciers and the deserts, desertic winds, and very small portion on the underground water, and some portion of the coast on the action of the waves. So he changed the idea of his cycle of erosion theory to accommodate all these to explain that in any of these stages, whether it is river, whether it is a glacier, whether it is underground water, whether it is wind, whether it is coastal waves, the landform will have a similar kind of manifestation of youth energy, mature energy, and the old age or senile stage of the low energy level of landforms. So in a river, when low erosion landform means it is a deltaic situation. Rivers are bringing a lot of sediments, but the carrying capacity of the river is not more because the slope has reduced in the meantime. So sediments will start depositing. Formation of deltas will take place, depositing the materials on the delta. So this is where actually the senile stage of the river is coming. That means it is no more carrying capacity, having the carrying capacity to take the sediments which are coming within. So when the carrying capacity is not there, what will happen? Sediments will deposit here and there, here and there. So there will be bifurcations, and then distributors will come out. So that is how deltas will start panning out. So in the old days. So this is how he started explaining. So one of the problem he resolved through his logic is climatic accidents. It can be considered as climatic accidents, and then we can think of a little modification or variation of the climate from the fluvial to a glacial climate will have glaciers, or fluvial to a dry climate will have winds like. And then another problem he came to explain, there was a criticism to his theory, that if this is happening, and the initial stage of explanation is that all landforms has to attain a particular height above the sea level, then only the erosion starts, is not to be an acceptable paradigm. So critics started criticizing the very beginning of the theory that was given by Davis. So at that stage, Davis and then tried to explain that landforms are also throughout the time of erosion and weathering till youth to the old days. The landform is also not static, not necessarily over the earth's surface. Every place is static. There are dynamic nature of the landscape. Land is rising somewhere, land is going down somewhere. So you cannot say that everything will operate in the same way as you are proposing in the theory. So that was again becoming a difficult question before this critical observation of the opponents. The critics started looking at this, to which he started saying that yes, so all those landforms are possible. There can be a second cycle of erosion or there can be polycyclic evolution. That means when a cycle ends and the river is forming a delta and the river is almost reaching to the plain, and then it has formed a peneplain, a plain surface with mounts, small mounts here and there, and the entire area which has been uplifted to above a sea level is now close to the sea level again with some mounts here and there. But if again upliftment takes place in the same area, then what will happen? There has been a valley, so valley will be uplifted, and within the valley there will be another set of valleys. So that will be a valley inside one valley. One valley is here, then there is another set of valley below this. So there are step-like formations here. This through this step will come to this valley, and then it will go like this. Then there is another step. So this is what we call the terraces, paired terraces. So at many places over the rivers, you can find paired terraces, which are indications of that the land has been uplifted and there have been valleys of second cycle has been formed. And in the meanders also there will be second set of meanders. Once the meander was moving like this, then within the meander also there is another kind of meandering that is called entrenched meander. So like this, he tried to defend his theory of second cycle or polycyclic evolution. The cycle does not end only. Human cycle just ends with one life, but the landscape cycle does not end always when there is upliftment. There is a second cycle, there is a third cycle is possible. So polycyclic evolution is possible. So this is how he started putting up the theory in a ergodic manner. Ergodic manner means a lot of energy at the beginning, gradually energy coming down in doing work, ultimately reaching to the senile stage where there is no energy more to work further. So this is what is a kind of cascading system of energy transmission through the landform change. Somehow or other, this particular theory was becoming very convenient for many people to explain the landforms across the globe. So wherever people wanted to study the landforms, using this principle, using this mannequin or using this model, we can call it as the model of cyclic evolution, was used by the earth scientists to explain the landform formation very conveniently, very easily, without much of difficulty. So it was easy for everybody to accept the theory, although there were a lot of criticisms. So from 1850 to 1950, William Morris Davis ruled the world of geography and geomorphology to be called as the father of modern geography. He was the person to be called as the father of modern geography, giving a foundation to the physical geography of landforms. And that was the theory when he put forth. Another critic of this theory was Walter Pack. He was a German mathematical geographer. So his theories of presentations of landform evolution was more mathematical and more geometrical than the realistic situations of Davis. So Davis was more realistic based on his field work. A lot of field examples were there to explain his theory. So he was explaining if this is a landform from where he has observed how it looks like this, what is the characteristics like this. But Peng started looking at the theory in a different way. The different way means right at the beginning of Davis was not accepted by Peng. Peng believed that there is nothing called a standstill stage that the cycle of erosion will operate. Continuously there is upliftment and erosion going on. So when there is a continuous upliftment and erosion going on, in the initial beginning of the system, V-shaped valleys can be formed, gorges can be formed. So though no need of a youth energy because landform is rising and the river is moving over. So ultimately the river is also eroding in the valley. So by rising level, the valley is becoming V-shaped. So not necessarily that only gradation is going to create the V-shaped valley. So upliftment itself is also going to create. So there are areas over the Earth's surface where such type of things are happening. Then he contradicted another important concept of Davis. Davis wanted that slopes are declining, so that ultimately the last landform is a plain land with mounds, truncated surface mounds. To his, Planck again stated in a geometric way that I gave you the example of the triangle. A triangle is like this. Then within this there is a small triangle. That means everything is changing and it is coming to a small triangle with the same type of peak. Then again a small triangle inside. So ultimately the last landform can also be a triangle of a very smaller dimension, but it is a triangle with a peak. That means it implies that slope is going through a parallel retreat process. Slope is going through a parallel retreat process. So that is the slope declining process of landform evolution. Planck's theory was explaining about the parallel retreat of landform. So by this process, when there is a decreasing upliftment, then obviously there will be a standstill stage will be coming and the valley widening will take place. So the way Davis was trying to explain the V-shaped valley from the undercutting and lateral cutting for the mature river valleys and meandering plains, the same thing was contradictorily done by Planck as upliftment and erosion creating V-shaped valleys, then declining upliftment and creating, because when the slope will decline, upliftment will decline or come to a standstill stage, then the river will cut its valley laterally because there is no vertical cutting once the rising stops. So this is how he started explaining that the same landforms which are created in the mature stage can happen when there is a decelerating upliftment. When there is an accelerating upliftment, the features which are explained by youth is possible, and the features which are explained by Davis in mature stage is possible when there is a decelerating upliftment. So that is how he created a contradiction to the. So ultimate landforms was he gave the name as a panplane. Peneplain was the name given by Davis to the ultimate landform that remains as a remnant at the end stage. To which Peng told that it is not the panplane, it is not absolutely plain with truncated surfaces. There will be also small hillocks, there will be small peaks, there will be small mountains, and like this, the landscape will be a different type of, not necessarily always a plain. It can be a rugged topography also. So this is how the contradiction between these two theories and every component of the landform evolution was addressed by these two non-cyclic approach and the cyclic approach. But the second man, Walter Planck, lived for a very short time. All his publications were in German language. So people could not know what he was talking about. Very few people knew about that at that time. And he passed away very early in 40s. So for which his theory also could not got published in English. So many people could not know him till his death. After his death, when all his literatures were brought out to the public, it took a long time, and people started looking at trying to understand language, and then translated into English. All these things came a little late by that time, and this cyclic theory was establishing itself as an acceptable theory for its easiness of understanding and workability. So that is how these two theories explain about all the different features that is produced in different agents with different agents across the globe. So these are the two theories which you will encounter at the landform formation. Then subsequently comes to the slope evolution theory. So in slope evolution theory, what happens? When you look to a mountain from a distance, you see there is a peak, there is a crest, there is a peak and crest, and then there is a side slope, and then there is a basement. So the slope is like this. You can see that this is what is a mountain. If you imagine this is a mountain, so there is a slope on this side, there is a slope on this side. So this slope is when the mountain is changing its form, it has to come down to a smaller one gradually by eroding at the top, eroding at the sides. So what is going to happen? So this is a now this is a straight slope, but it can be a concave slope like this. You see the concavity is there. The mountain slope is concave. What is happening? Materials are coming down, depositing here, partly depositing here, and the convexity, concavity is coming like. Or there can be a mountain where the changes may happen like this, also bulging. The mountain can also bulge like this. So there is a bulging on this side, and then there is a depression. So like this, there are various ways in these geometrical shapes in which the mountain can change its slope. So this is what was also you are supposed to be the theory of slope change, where you will find Davis theory of slope declining, Planck's theory of slope retreat, parallel retreat. Then there are other theories of slope evolution also that explains about what is the level of the free face, and then how these slope materials move, what are the conditions responsible for the movement along the slope, where concavity can occur, where convexity can occur, and then how the convexity and concavity will progress towards declining the mountain slope. So these are some of the theories which are we are likely to encounter. So these are the major theories which you are supposed to be passing through in your geomorphology course. So next class onwards, I will systematically take you through the courses, and whatever the left out important points, we will discuss on that. Okay. So would you like to have any question or anything?
Good evening, sir.
Yes, evening, Sangeeta.
Sir, I just want to know how estuaries are formed.
Estuaries are formed.
Hmm.
So we have not yet come to that topic, but anyway, estuaries are formed when a river is meeting the sea at the mouth region. When the tides are entering into the river, what is happening? The interaction between the river water and the saline water, sea water, through the mouth actually creates a kind of pressure on the river mouth to, suppose this is the river mouth, if you can imagine. What will happen? This tide will enter into the mouth. It will enter through the mouth. So when the tide will enter through the mouth, what is going to happen? This portion will be eroded. This portion will be eroded gradually with the force of the tide. And tide has a tendency of moving the water from the higher depth to a lower depth. So it is moving like this. The tide water will move towards the land in this way. That means the bed will be scoring. So when the bed will be squaring, these two edges of the mouth will be gradually eroded. So ultimately the river mouth, which was like this, at some time point of time it will open like this, like a funnel. So a river with a funnel shaped mouth, with the effect of the tidal movements, creates a situation of river mouth to which we call it as a estuary. This is what is an estuary, where you will find the river mouth is wide open in a funnel shape. The mouth of the funnel is like this. It will be very difficult for you to know where the river mouth is actually. You may feel that this is the river mouth or this is the river mouth. Initially it was like this, but this thing has been eroded gradually and then mouth has been expanded like this. So this is what is estuary. But in a delta what happens? The river straight enter into this. No expansion of the river mouth. But when there is estuary in river, the mouth will start like this. This is what is estuary. Are you clear?
Yes, sir. Thank you, sir.
If there would have been a scope to explain you through the PowerPoints, I think it would have been better, but I don't think we will have enough time to discuss all those things over the diagrams. Otherwise, but if you find any difficulty somewhere in some point, we can get into those PowerPoints. But I think it will not be. Last class I will show you, if possible, tomorrow, the next class, if I finish all the courses in a very narrative way. The fourth class we may devote to some of the PowerPoints to just look into each and every things in one or two slides. Like that, I will try to do that so that the whole clarity of the things will come to you from the beginning to the end. The last class, if you feel like, we can have that day after
Yes, sir.
tomorrow.
Sure, sir.
So you can know what is the story, but by explaining in just like this,
Yes,
it
sir.
will be a very clear concept. But if you look to a
PowerPoint will
remote,
be more
yes,
appropriate, sir.
that's more appropriate to see that
Thank you,
this is
sir.
what the story looks like and different from a normal river entering into the sea. Well, if you look to a beach, no, somewhere it is a muddy beach, somewhere it is a sandy beach. Why mud is coming, why sand is coming, somewhere why rocky is there. We call rocky beaches in the west coast of India. What is the reason for that? Like this, there are many things which are supposed to be understood from that point of view. We'll try to see that in the last class.
Okay, good evening, sir. As we are discussing about estuaries and deltas, I was having doubts since many days. Why does it is only east flowing rivers of peninsular India? They
Hmm.
are forming the deltas, but the west flowing rivers are forming the estuaries. Is there any specific reason?
Yes, you have asked a question that you are going to face in every interview. This is a question whenever you appear to any interview in geography, you will be asked this question in the beginning. Why East Coast rivers are producing estuaries? Why West Coast rivers are not producing estuaries? The reason is West Coast is a faulted coast. East Coast is not a faulted coast. So when it is a faulted coast, what is happening? So there is a crack, and from the crack the landmass has shifted. So what is happening? If you go to Kerala coast, what is happening? Kerala has come down from a crack like this. So there is sea here. The depth of the sea at the coast is so high that you cannot enter into the sea. You just cannot. You can walk into the sea at Puri, but you cannot walk into the sea in Cochin or nearby places, except a few points where you can. But most of the places you cannot because the depth is very high. Because it is a mountain from where the crack has happened and then the continent has come like this. This is Kerala coast and the sea is over here and depth is like this. It is a straight coast and depth is about 200 to 300 feet just immediately to the shoreline. So whatever the river materials will be coming, they will be getting into the sea, but the tide is not able to push into the river. But here, if you come to River Mardi, tide will be entering into the river mouth for about 25 kilometers. If you get into Baitarani River, Brahmani River, tide will be coming up to Danvali, and that is about 60 kilometers from the river mouth. So if tide water can come 60 kilometers, the 60-kilometer length of the river is almost a estuarine river. The mouth has a estuary where the sea level will be rising and falling, just like Hooghly estuary. When there is high tide, Hooghly estuary is having about 20 feet, 25 feet of water. When the tide is no more there, it is about 10 feet of water. So 10 and 25 mixed together is 35 feet. So you can imagine a 35 feet depth of water when there is a high tide, and when there is a low tide, only 10 meter of water, the water level rises. Similarly, everywhere, wherever there is, but here in this situation, in the river, you cannot, because it is in the depth, water will not reach to the river mouth to enter it. The slope is not congenial. So deposition could not take place on the river mouth. So unless deposition takes place, delta formation cannot take place. But if it is a shallow sea like our east coast of India, wherever you go, you will find a shallow sea. It is not a faulted coast. Shallow sea means the sea level and the land level are relatively close to each other, not like our west coast. So because of that, waves will be pounding on the shore, breaking the rocks, depositing the materials. The river will be bringing the sediments, taking into the sea, and then coming into the sea, and then waves again will be bringing those some of the sediments again to the beach and depositing along the beach, and then decline in the slope. The river sediments will also not drain to the sea. Everything, something will be deposited behind the mouth, and delta formation will continue. Whereas nothing is possible like this in the west coast, because the west coast is a steep coast. So when it is a steep coast, you will also not find waves. You don't find waves. Waves come with the force of water against the slope to rise the water. If it is shallow, things are possible. If it is not shallow, then the wave energy is, the energy of the wind is absorbed there, water will not rise, so you will not find the waves. So you will see the sea like a pond in Cochin. You will see the sea like a pond in Trivandrum at many places, except some occasional
Okay, sir.
places where
Thank you.
beach has developed occasionally at some places. And those some places have been named with a lot of advertisement that they are the beautiful beaches of West Coast. But they are not actually that beautiful like our Puri coast or Konark coast. But they are, what is happening? There are mountains along the coast. So they are secluded coasts. So somebody is standing here, he cannot see another person standing on this side. So this is a seclusion. If a group of people are here, nobody can see them, that here is somebody. So that is the loneliness, that is the privateness it provides in those beaches and very small beaches. And hotels are nearby, so people take advantage of that. And then, so that is how those beaches are advertising for that good beaches from the west coast, like Kovalam Beach and many other beaches that you come across. Goa Beach or different type of beach names are because of this. But they are not beaches like our Marina Drive or Marina Beach, or like our Konark Beach or Puri Beach or Vizag Beach also will be extensive sand deposits. You stand on one side of the, look for 3-5 kilometers from the beach itself. You can see for a long distance.
Yes, sir.
Okay.
Thank you. Sir, our peninsular plateau has been divided into Deccan Plateau and the Central Highland. On the basis of what this division has taken place?
Again.
Sir, our peninsular plateau has been divided into Central Highlands and the Deccan Plateau.
Mm.
My question is on the basis of what this division has taken place.
Okay. The basis of division is Deccan Plateau is a plateau, the origin from the volcanic eruptions. Fissure eruptions during the Mesozoic era, Cretaceous period, volcanic eruption has happened over the Deccan Plateau in the form of fissures. A lot of volcanic lava has come up and has been spreading over and deposited over, and in course of time has been converted into a dark soil. Dark soil, that is what is Deccan soil, call it, or the Deccan area we call it. So that is the province of the Deccan was the name, the historical name, and it covers parts of Telangana, parts of Maharashtra, parts of Madhya Pradesh, parts of Karnataka. So this is the area that is being covered. So on the basis of this volcanic eruption and the black soil, black soil or the black soil that is available across, based on the origin of the volcanic eruptions, Deccan Plateau has been identified from the Peninsular Plateau. Peninsular Plateau covers everything that remains south of the Ganga Valley. South of the Ganga Valley up to Cape Comorin, everything that remains is a part of the Peninsular Plateau. So within this Peninsular Plateau, Deccan Plateau is one geological origin which is volcanic in nature. And at the northern part of this Peninsular Plateau, we have the Central Highlands because that is located at the center of the country. So we call it a Central Highland. Means this Vindhya Satpura mountain system is called as the Highlands. That's how the name has come. It is geographical, and here it is geological analysis. So that is the basis on which they have been classified and differentiated from each other.
Okay, sir. Thank you. Yes, sir. Thank you.
Okay, I think we'll keep it here
Yes, sir.
and see tomorrow what we'll be discussing. I will take you to the courses of study and after the mock
Hello, sir.
Yes.
Sir, ଆମେ ଏଇ କ୍ଲାସ ଟାକୁ 6 ରୁ 8 ରଖିପାରିବାନି କି? ମାନେ 6 ରୁ 8 ରଖିଥାନ୍ତେ ଏଇ ଯୋଉ କ୍ଲାସ ଟା ହେଇପାରିବ କି?
6 ରୁ 8 ରଖିବା ଯେ ମୁଁ ତ କହିପାରିବିନି because this is the time given by your IGNOU, so they have to decide. I cannot decide. It is their
4 ରୁ 6 ସାର୍ ଜଏନ୍ କରିହଉନି, ମାନେ ଜଏନ୍ ବି କରିହଉଛି।
ତମେ ତାଙ୍କ ସହିତ ଡିସ୍କସ୍ କର, you can take a discussion with them and ଆମେ ତ will try to make ourselves available. ML जो time slot ହବ କିନ୍ତୁ but you have to discuss with them because we cannot take a decision. I cannot take a decision independently. This is a time slot given by the IGNOU themselves. And you can discuss your problems with them. ସେମାନଙ୍କ ପାଖରେ ଅପସନ ଥିବ ନା, ତମ ପାଖରେ କିଛି ତାଙ୍କ ସହିତ ଇଣ୍ଟରାକ୍ସନ ତ ହଉଥିବ ନା?
ନା ସେମିତି ତ କିଛି ନାହିଁ ସାର୍, ମାନେ ମିଡିୟମ
ନାଇଁ ମିଡିୟମ ନାହିଁ ମାନେ you can ତମର ତ ଥିବ କଣ୍ଟାକ୍ଟ ପଏଣ୍ଟ ଥିବ ନା from the IGNOU ଭୁବନେଶ୍ୱର ସେଣ୍ଟର।
ଇମେଲ ସାର୍, ଇମେଲ ହିଁ ଅଛି ଯାହା।
You can message. So you are finding inconvenience of these things. So you can convey your things. Email ର ଅଛି, phone ବି ଥାଇପାରେ କାହାର ଯଦି contact person ଥିବେ, use the mail and convey.
Okay, sir.
ହଁ ସେମାନେ found out ଆମକୁ କହିଲେ ଆମେ ମାନେ we can help you in some way କେତେଟା class କରିପାରିବା, କିନ୍ତୁ କିଛି ନାହିଁ, you can have a change time. କିନ୍ତୁ କିଛି ସର୍ଭିସ ହୋଲ୍ଡର ଯଦି ଥିବେ ଡିଫିକଲ୍ଟ 4ଟା ବେଳକୁ ହେଲା ବେଳକୁ ହଉଥିବ ନିଶ୍ଚୟ ରିଏଲାଇଜ, କିନ୍ତୁ ସେମାନଙ୍କର କ'ଣ ଥିବ କନଷ୍ଟ୍ରେଣ୍ଟ ମୁଁ ଜାଣିନି। ଆଇ ଡୋଣ୍ଟ ନୋ, ଆଇ ଏମ୍ ନ୍ୟୁ ଟୁ ଦି ସିଷ୍ଟମ। ତମ ସିଷ୍ଟମକୁ ମୁଁ ବି ନୂଆ, ଏ ବର୍ଷ ଆସିଛି, ମୁଁ ଆଗରୁ ନଥିଲି, ନଟ୍ ଆସୋସିଏଟେଡ ୱିଥ୍ ଦିସ୍ ଇଗ୍ନୋ ବିଜନେସ୍। ଏଇ ବର୍ଷ ଆସିଛି, ତେଣୁ ମତେ ବି ବିଶେଷ କିଛି ଜଣା ନାହିଁ କି ମୁଁ କାହାକୁ ତାଙ୍କ ବିଷୟରେ ବି ଜାଣିନି ବର୍ତ୍ତମାନ ଯାଏଁ। ମୋର ତ 2ଟା କ୍ଲାସ ହେଲା ମାତ୍ର, ଆଇ ଡିଡଣ୍ଟ ନୋ ଏନିବଡି ଅଲସୋ ଫ୍ରମ୍ ଦେୟାର ଅଫିସ ହିୟର ଇନ୍ ଭୁବନେଶ୍ୱର ଅଲସୋ, ଆଇ ଡୋଣ୍ଟ ନୋ ଏନିବଡି। ଏଇଆ ହେଇଛି, ବଟ୍ ଇନ୍ କୋର୍ସ ଅଫ୍ ଟାଇମ୍ ଆଇ ମେ whenever there is a chance I will communicate ଯେ ପିଲାମାନଙ୍କର ଏମିତି ଟାଇପର ରହୁଛି, ବଟ୍ you convey that in the mail, ହେଲା ଯେହେତୁ ମେଲ୍ ଦେଇଛନ୍ତି। Yes.
ମୋର ଗୋଟେ ରିକ୍ୱେଷ୍ଟ ଥିଲା ସାର୍, as we are having for geomorphology only 4 classes, we are having a WhatsApp group including the faculties, and no personal message or anything would be there, but in case of necessary, how we can contact you?
ମତେ କେମିତି କଣ୍ଟାକ୍ଟ କରିବ ସେଟା ତ ମୁଁ କହିପାରିବିନି। ତମେ ସେ WhatsApp ଗ୍ରୁପରେ ମତେ ଇନକ୍ଲୁଡ କରିଦେଇକର।
ଆଜ୍ଞା ସାର୍, ଆପଣଙ୍କ ନମ୍ବର ଦେଲେ ଆମେ ଆଡ୍ କରିଦେବୁ, just for this session only, and we will not disturb you. There will be no personal message, only if any query will be there regarding geomorphology, we will ask the question in the group.
ନାଇଁ ଠିକ ଅଛି ଯେ ଏଇ ଗ୍ରୁପଟା କରିଛି କିଏ? It is among yourself or
No, it is among ourselves, but then Malini madam, she is also included. She was teaching us geographical thought. So as sir, ସେଥିପାଇଁ ସାର୍ ଆପଣଙ୍କୁ ବି ଟିକେ ରିକ୍ୱେଷ୍ଟ, ଆପଣ ଟିକେ ଗ୍ରୁପରେ ରୁହନ୍ତୁ ଆଟଲିଷ୍ଟ ଏଇ ସେସନ ପାଇଁ।
ଗ୍ରୁପରେ ରଖ। I can answer your things. If I have something to answer, I will answer definitely. Okay, phone number ଦେଇଦେବି। If you want to record it, you can record it, 94373. Note it. Note କରିଦିଅ। କରୁଛ, ନୋଟ୍ କରିବ?
Again, sir.
94373
Again.
02280.
94373 02280, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay. Wish you all the best. We'll meet tomorrow. But tomorrow I will try to meet exactly at 4. So please join accordingly.
Thank you, sir.
Okay.
Thank
Let
you,
me
sir.
stop this way. Okay.
Yes.
All- My point is,
Thank you,
are you
sir.
getting the idea of things? Understanding is proper?
Yes, sir.
Yes, sir.
My point of making the classes is to make your doubts clear and make you a little more comfortable with the subject in a way that you can complete it like a story and start writing of your own without depending book language. Book language is knowledge ki nije କେମିତି understanding ରୁ ଲେଖିପାରିବ. That's my approach. That is how I am trying to address to the topics. ତେଣୁ ମୁଁ ସେଇ ଭାବରେ ଚେଷ୍ଟା କରୁଛି ତେଣୁ I am trying to do that. ଯଦି ତମର difficulty କହିବ and another thing that you need also you may specify. Okay.
Yes, sir. Many fundamentals have been cleared through you, sir.
ନାଇଁ ହବ because of our experience definitely will be gaining much from us. That obvious. Provided you are using your time. Time ନେଲେ ତ ଭଲ ଲାଗିବ. And
Yes,
many interesting things you will also know in course of time. The geography is something that is interesting and puzzles can be resolved in a various ways. That will be your experience. And subject will be a subject of happiness. That's also. Okay, ଦେଖିବା we'll see in the subsequent classes. Okay.
Again. Yes.
ମୁଁ ତ ରହିବି available ତମ ଦେହ ଫ୍ରେଶ ସରିଲା ପରେ I may come in some other subject again. Your batch. I will be
Trimester is sir.
not only this subject. There will be many other subjects where I will be coming.
Trimester is
So we will have enough scope to interact. There is no problem. Okay.
Okay, sir.
Okay. Thank you then.
Thank you, sir.